Alright, so today's lesson is on comparing box. So the first thing we're going to go ahead and do is just look at one single box plot just to review some of the terms that go along with it. So our first one is our 5-number summary. The 5 numbers used to create the box plot. We have our lower extreme, quartile number 1, the median, quartile number 3, and then our upper extreme. So I'm going to go ahead and do just an LE for my lower extreme. My lower extreme is the lowest number that I have there, the lowest data point. And in this case, for Noah's test grades, looks like he scored a 20, would be his lowest extreme. Okay. Then I also have my quartile 1. Okay. Quartile 1 is going to be the beginning of the box here. Okay. That's where the 25th percentile starts. Alright, so it looks like that is a 50. Alright. So his lowest grade was here, and then this is his bottom 25% of his test scores right here. Okay. The next 25% of his test scores comes in this area right here. Okay. Giving me up to the median, which is his 50th percentile, which looks like his median is a 55. Then I have my next 25% of my scores leading up to the 75th, which would be my quartile 3. Looks like is a 70. And then the last 25% of the test scores is this part right here, leading up to the highest, which is my upper extreme, which looks like is an 85. So our box plot shows that it's going from a 20 to 85 possibility, which is exactly what my range is. It's the difference between the maximum and minimum values of the distribution. So the maximum is 85. That's my upper extreme. And then my minimum is my lower extreme, which would be 20. So I have a range of 65 points. Okay. If I look at my interquartile range, this is the difference between the quarter 3 minus the quarter 1. And it's where the middle 50% of the data can be found. So it's from that 70 to the 50 right there. So my quartile 3 was 70 minus my quartile 1, which was 50. So there is a 20-point difference, okay, between those two. Next one says symmetrical, characterized by or exhibiting symmetry. It's well proportioned as a body or a whole. It's regular in form or arrangement of corresponding parts. Basically meaning that when we talk symmetrical, we're talking about that all of the quartiles, all the ranges of 25%, all match. Okay, and so this would be an example of a symmetrical box plot right here. Okay, you go from 0 to 10 would be 25% of the data, 10 to 20 would be another 25% of the data, 20 to 30 would be another 25%, and then 30 all the way down here to 40 would be my remaining 25% of the data. Okay. Alright, and then my median would be exactly in the middle, exactly 20. 20 is directly in between 0 and 40. If we look at my example up here, I know I've written on here a lot, but this definitely does not show symmetry. There are some areas that have more data points than others, which leads us into clustering. It's a group of things or persons close together. The part we can see the most clustering with is my range right here. This 50 to 55, okay, there's going to be 25% of my data is in this little area right here. Okay, so there's where clustering is shown. So I'm going to go that 50 to 55 has 25% of the data. That is where I would see some clustering. Alright, so let's go ahead and compare a couple box plots now. Okay. My first one talks about Tim and Joe, talking about some test grades by them. Okay. So if we look at my two box plots right here, I have Tim's at the top and Joe's at the bottom there. First one that wants to ask me to do is find the median, the range, and the interquartile range for Tim and Joe. So I'm going to go ahead and do a little line here. Let's go ahead and find Tim's over here. We're going to find Joe's over there. First one it asked me to find is the median. Okay. over here. We look at Tim's graph over here. Our median is right here, right at 55. And it looks like the median for Joe is the same. So if we compare those two, they have the same median, the same middle grade. Next, it asks me to find the range. Remember, the range is the upper extreme subtracted by the lower extreme. So my upper extreme for Tim here is 95. My lower extreme is 20. 95 minus 20 gives Tim a range of 75. For Joe, my upper extreme is 85. The lower extreme is 35. 85 minus 35 is 50. He has a range of 50. Okay. Alright, and then we have the interquartile range. Remember, this is my quartile 1 and the difference between my quartile 1 and quartile 3. So for Tim, I have a quartile 3 of 75 and a quartile 1 of 45. 75 minus 45 is 30. I'm just going to do interquartile range, IQR. Alright, then my interquartile range for Joe, he has a 70 for his third quartile and a 45 for it, giving him an interquartile range of 25. Okay. Alright, so I'm going to go ahead and use the medians to compare the students' grades. Like we said before, they have the same median, which means both Tim and Joe have a middle score, we could say, or median of 55. Okay, so they're both the same. Right. And then use the interquartile range to compare the student's grade. Interquartile range for Tim was 30. Interquartile range for Joe was 25. Joe has a smaller interquartile range, which means his data points are going to be closer together. Okay, so we'll say Joe's smaller interquartile range shows his scores in the, we'll say in the middle, in his middle 50th percentile. Middle 50th percentile. Are closer together. Alright, then if we look at their ranges, we're going to use the range to compare the students' grades. Again, same thing, we find that Joe's range is a 50 and that Tim's range is 75. So Joe's range, Joe's smaller range, shows his scores, again, are closer together. Alright, and then we're going to use the evidence of cluster and or symmetry to compare my students. If I go ahead and look up at my graph up here, I can already tell by where the median is that I do not have for Tim's any symmetry in it. And then for Joe's, same thing. I can tell that Joe right here from 45 to 55, that 10-point swing has 25% of the grades. And then over here, we have from 50 to 70 or sorry, 55 to 70, that 15-point area has another 25%. So my 10-point swing and my 15-point swing don't match. But what I can see is there is some clustering here. If we look at Tim's, the majority of his data is going to be in this lower quartile here. Okay, this 25% to 50%. For Joe, we're actually seeing, not only is it from 45 to 55, just like Tim's is, but Joe also sees another 25% of his grades coming from 35 to 45. So the clustering for Tim, okay, where the most data points are going to occur is from or they're going to be closest together, we can say, is going to be from 45 to 55. And then for Joe, we can say his are going to be from 35 to 55. Okay. So no symmetry there, but a little bit of clustering for both. So what I'd like to go ahead and do now is pause your video. Get him out of here. Alright, go ahead and pause your video and go ahead and complete our comparisons of Tim and Joe's earnings. Okay. Make sure you answer question number 5 as well. So you can see them all at once. Okay. And after you try that on your own, you can go ahead and see how you did. Alright. So we have our graph here. Alright, so the first question talks about the median range and the interquartile range. Those are the values that you should have gotten. Alright, second one is the median to compare them. We see that Joe's median is higher. So we know that Joe probably makes more money. Then we have our interquartile ranges. We actually found that they're the same. This means that the middle 50% is the same. Remember, it's not the same amount though, but it's the same variation. So if we look up here at our graph, the variation for Joe, that middle 50%, is 120 to 160, which is 40. Same for Tim. It's not 120 to 160, but it's 100 to 140. Still gives a variation of 40, variation of 40. So different amounts, but same variation where I'm saying. Then if we look at number 4 here, we have, talks about the range of them. Should have found that Tim has a range of 90 and Joe has a range of 80. Joe's smaller range shows that he has a little more consistency in his earnings. And then last one we have, is there any examples of symmetry or clustering? We said that Joe does show symmetry. So if we go back over to Joe's, we can see that there is a 20-point difference, alright, in the bottom 25 percentile. Then if we go to the next 20-point difference, that's another 25 percentile. Another 20-point difference there, another 25 percentile, and another 20-point difference gives me my last 25th percentile. So there's 4 quarters here broken up by the same range, that 20 points. Tim's, on the other hand, we said shows clustering. His shows clustering in this quartile right here. All right, that first quartile spot to my median is where the data is going to be the closest together. Okay. So that is our lesson on comparing box plots.